Okay, how would you name the top one there? Well, we want the name. It's 5-methyl 1-hexanol. Okay, the one underneath it. So there's 1, 2, 3, 4, 5, 6, 7. So it's 5-methyl 2 what? Heptanol. Okay, and the one on the right, top right. All right, so it's 2-methyl 2-pentanol. Okay, now, Alejandra, the top one is what kind of an alcohol? Primary. Okay, someone else. The one below it is a secondary. And the top right, someone else. Tertiary. Even though it says 2-pentanol, all right, that's not telling you it's a secondary alcohol. There's a methyl group on that same carbon. So that's a tertiary alcohol. Okay. Let's move on now because we're going to start learning how these react. We're going to look at the oxidation of alcohols and primary, secondary, and tertiary oxidize differently. Let me just take a peek at the homework. I'll be giving this to you soon, very soon. Okay. Yeah, we're going to look at 3 reactions. One you already know, and that's the hydration of an alkene. That's how you can prepare an alcohol. You can prepare alcohols by hydrating alkenes. Reacting alkenes with water produces an alcohol. And then you can dehydrate an alcohol. We're going to have to learn that reaction. What is the dehydration reaction of an alcohol? And then in the middle of the back page here is the oxidation of alcohols. So we'll in 15 minutes or so you'll have this in your hand.
What kind is methyl?
Well, this one is primary, this one is primary, and that one is secondary. So you have to look at each OH and say what kind of an OH is that. So that's a mixture. It's got an OH on each end, it's got an OH in the middle. So 2 of them are primary OHs and 1 of them is a secondary OH. Good question. Complicated molecule. So if we went to oxidize that one, one would wonder what we would get. We won't worry about that one. Okay, again, let's run from the left to the right. Just primary, secondary, or tertiary? Primary? Secondary? Secondary? Okay, this one is interesting here because this is a primary. But don't get confused by it. Over here you see a whole bunch, you see a carbon with a bunch of carbons on it, but there's no OH on that carbon. The OH is over on this carbon. So that OH is on that carbon, and how many carbons is attached to it? 1. Don't count those 3. How many carbons are directly attached to the carbon that has the OH. Only one. So that's a primary alcohol. Now, this molecule kind of looks like this molecule, but what kind of alcohol is that?
Tertiary.
Tertiary. Now we've got the OH on a carbon that has 1, 2, 3 carbons on it. That's tertiary. All right? All right, so now we get into the reactions of alcohols. The first one would be, how could you prepare an alcohol? Well, you could make an alcohol by the hydration of an alkene. So here's propene, and if you hydrated propene, the hydration of propene, you could get 1 propanol and 2 propanol, but the major product would be 2 propanol. That's your major product. Why? Because of Markovnikov's rule. The hydrogen is going to go to this carbon with the most hydrogen, and the OH is going to go to the other carbon. All right, so you already know that reaction. We're going to just jump right past that, but yes?
So you said the one on top is the minor product and the one at the bottom is the major product?
What's it say?
Oh no, it's the other way around.
Yeah, the one on the top is the major product. Yeah, major. This is the isopropyl alcohol. That's the major product. Is that, you got it, Alejandra? Okay. Oh, here's another way of preparing them. I should kind of leave this for last. Yeah, let's try to come, I always say that and then I forget to come back and explain this one. This is the hydrogenation of a carbon-oxygen double bond. You can make an alcohol. This is another way of preparing an alcohol. Now this one is a little bit more challenging for you right now because you haven't studied aldehydes and ketones yet. This is an aldehyde, this is a ketone. You have studied hydrogenation. But here, in hydrogenation, you studied the hydrogenation of a carbon-carbon double bond, right? And each carbon got a hydrogen. Well, let's look at this one right down here. And we're going to hydrogenate that. Hydrogenation. We've got a double bond. You say, well, that's a carbon-oxygen double bond. Yeah, it is, but it's a double bond. When we had a carbon-carbon double bond, 1 hydrogen went on that carbon and 1 hydrogen went on the other carbon. Hydrogenation. Well, this hydrogen is going to go on that oxygen, and that hydrogen is going to go on that carbon. And we're going to get rid of the bond. Remember I said you have these electrons in here and form these 2 new bonds. So what are you going to get here? An OH group. You made an alcohol. By the hydrogenation of an aldehyde, you get an alcohol. And what this slide is trying to point out right here is if you hydrogenate an aldehyde, you get a primary alcohol. If you hydrogenate a ketone, what is a ketone? A ketone has the carbon-oxygen double bond in the middle somewhere. And if you hydrogenate it, you're going to get a hydrogen on here, and you're going to get a hydrogen on that oxygen, which is exactly what you end up with here. And you get a secondary alcohol. All right, so this is, again, there are two ways to prepare alcohols that we now know. The hydration of alkenes or the hydrogenation of aldehydes and ketones. I don't know that I've got that reaction on the homework. Probably should. Okay, now under the category of, okay, how do alcohols react? Not how do I prepare them, but how do they react? Well, one thing you can do with alcohols is oxidize them. Oxidation of alcohols. These are oxidizing agents. That's potassium dichromate. This is potassium permanganate. But sometimes when we don't know or just want to say, okay, in the presence of an oxidizing agent, in general, without saying, okay, what is that oxidizing agent, we'll just put in an O in brackets and we'll put it above the line, not as a reactant, but as an agent that's going to help drive this reaction. And here's the rub. This is the important thing. The three classes of alcohols behave differently towards oxidizing agents. They're going to oxidize differently. So you're going to need to learn what a primary alcohol will do, what a secondary alcohol will do, what a tertiary alcohol will do. All right. This is a slide that will show up in chapters 12, 13, and 14 now. That will just show this repeatedly. What is oxidation? In 1305, you learned that oxidation is the loss of what? Electrons. Reduction is gain. Oil rig. Oxidation is loss. Reduction is gain of electrons. Well, in the organic system, we modify that a little bit. It still comes down to the same sort of thing, but oxidation is going to be gaining oxygen or losing hydrogen. When an organic molecule gains oxygen, it's gotten oxidized. Gains or loses hydrogen, it has gotten oxidized further. Or it gained some more oxygen, it got oxidized further. That's what's happening here. We're saying more oxidized form of the molecule. So if we started out with an alkane and added an OH group to it, we've added oxygen. It gained oxygen, right? That's oxidation. We don't need to go much further than that. We will in other chapters to see how we go here to there and everything. Coming back the other way, if we converted an alcohol into an alkane, we would be reducing it. All right, so gaining oxygen or losing hydrogen. Here, this molecule lost 2 hydrogens. Didn't get any more oxygen. It's had 1 oxygen, still has 1 oxygen, but it's got 2 less hydrogens. That's oxidation. And actually, to go from here to here, I can't write on the board. Stuff is pretty versatile. But you can see if I do the hydrogenation of this, add hydrogen to this, I get this back again. That's reduction. So hydrogenation, by definition, is reduction. It's gaining hydrogen. Whenever you hydrogenate something, it's gaining hydrogen. So it's moving to a more reduced form of itself. Okay, so let's look at a primary alcohol. On this slide here we have 1-propanol. It's a primary alcohol. And this one can actually go through 2 steps. A mild oxidizing agent, you can oxidize it from a primary alcohol to a aldehyde. This is chapter 13. But you should start getting familiar with that. A carbon-oxygen double bond on the end is an aldehyde. Why did it end up on the end? Well, that's where the oxygen was to begin with. Didn't move. When we oxidize this molecule, that oxygen doesn't move. It stays right on, but now we got a carbon-oxygen double bond instead of a carbon hydroxyl. We got a carbon-oxygen double bond, an aldehyde. And that can oxidize further to a carboxylic acid. It gained another oxygen right here. That's further oxidation. So a primary, this is a primary alcohol, can form an aldehyde, and then it can form a carboxylic acid. So it can go through 2 steps of oxidation. Let me just run through these 3, and then I'll get this homework in your hand, and you can start maybe working on the oxidation of these alcohols. Here's isopropanol, secondary alcohol, and it forms a ketone. It can only do one thing: go to form a ketone. It can't form a carboxylic acid. Carboxylic acids are always on the end of the molecule. Now, the tertiary you're going to like. Now, you may not have liked anything yet, but you'll like this one. Okay? It's a wild guess. Tertiary, no reaction. No reaction. They don't oxidize. So tertiary butyl alcohol, you can't oxidize tertiary butyl alcohol. You add an oxidizing agent to it, it just stays tertiary butyl alcohol. They're saying there's no hydrogen right here. There's a carbon, carbon, carbon. There's no hydrogen, so there isn't a hydrogen. There isn't a hydrogen to go along with that hydrogen, so this thing can lose 2 hydrogens. It doesn't oxidize. Yeah, it can't form a ketone, can't form an aldehyde. It just doesn't react. So, in summary, primary oxidizes to an aldehyde, which can then oxidize to a carboxylic acid. Secondary oxidizes to a ketone. Tertiary, no reaction. Okay, I'll tell you what, let me hand this out, and for 15 minutes, why don't you start having some fun with this homework? All right? What we just did was question number 5. If you want to turn to number 5 and try to solve those oxidation reactions, that'll solidify that. I would stay away from question 4 because I haven't explained that. I'll let you get a little bit started on this, and then I'll explain that reaction. Aldehyde, I just abbreviate. Everybody have one?
Okay, so when it's on the first carbon, there's no need to put a 1.
No. Yeah, I mean, if I had one hexanol, I would need a 1. Because if you just gave me the name hexanol, I wouldn't know what to draw. All right, it could be on the second or third carbon.
Yes.
Okay, so if there is the option for something else, then I need a 1. Now here's the deal. This is ethanol. And I don't put a 1 in it. Why not? Well, because, yeah, there's, it can't be anywhere but on the first carbon. No other place for it to be. So you get the propanol, it can be there, or it can be there. So I need to start designating which propanol. There are 2 propanols. There's a 1 propanol and a 2 propanol. So I don't just by default, if I see the word propanol, assume that means it's on the end. I have to specify. If it has 2 different places where it can be, then I need to specify.
The top is that 1 propanol.
No, this one.
So 2 propanol.
Yeah. This is 2 propanol or isopropyl. Isopropyl alcohol. This is 1. Yeah, I know it's confusing. When don't I need a 1? Okay, you don't need a 1 there. You don't need a 1 here. It doesn't matter where I put that OH, whatever carbon it's on, because they're all 6 the same. All 6 of those carbons are the same. No matter where I put that is going to be carbon 1. And if I put something else on there, then I'm always indexing it off of that. And now if I had this molecule, now I gotta use some numbers, because this could be there. Yeah. One's a 1 and one's a 3, and it doesn't matter which one. This could be 1, 2, 3. Or it could be 1, 2, 3.
So this is
Yeah. Because that, see, it could be on the second, third, and if it was on the other end here, that would be your 1, right? So that wouldn't be a 7. You're never going to get a 7. Right? If it was on this end, we would start counting from that. There'd be 1. So you'll never get a 7 heptanol.
Oh, yeah.
It would be named wrong. Yeah, if there was 1 on each end. Yes.
For this one, are we just writing the name like with all of them?
No. You gotta draw it. Yeah. You gotta draw the product.
So for this one, I'm not sure for these, I don't have to hold you, right?
No, just name them. Yeah.
For these ones, yes.
Yeah, draw them.